When wiring a house and calculating the electrical service size, it's important to account for all loads, including ceiling fans. The National Electrical Code, or NEC, requires a minimum of 3 volt-amps per square foot for general lighting. However, this calculation doesn't include the additional load from appliances, HVAC systems, or in this case, multiple ceiling fans. To accurately determine the service size, you must add the volt-ampere requirements of these additional loads to the general lighting load. Each ceiling fan typically consumes between 50 and 100 volt-amps. For this example, let's assume each ceiling fan consumes 75 volt-amps. If there are 15 ceiling fans, the total volt-ampere consumption for the fans is 15 fans multiplied by 75 volt-amps per fan, which equals 1125 volt-amps. Now calculate the general lighting load. The house is 3,000 square feet and the NEC requires 3 volt-amps per square foot. So 3 volt-amps per square foot multiplied by 3,000 square feet equals 9,000 volt-amps. To find the updated volt-ampere calculation for the service, add the general lighting load to the total volt-ampere consumption of the ceiling fans. Therefore, 9,000 volt-amps plus 1125 volt-amps equals 10,125 volt-amps. You should use a minimum of 10,125 volt-amps when calculating the service size for this house. This calculation ensures that the electrical service can handle the expected load of the general lighting and the ceiling fans. Remember to consider other loads such as appliances, lights, and HVAC systems when determining the final service size. It is also prudent to consider future electrical needs such as electric vehicle charging, which may require additional capacity. Always consult with the local utility or licensed electrician for specific requirements and recommendations to ensure compliance with all applicable codes and regulations. These experts can provide valuable insights and ensure the electrical system is safe, efficient, and meets the homeowner's needs. In summary, firstly, determine the general lighting load by multiplying the square footage of the house by 3 volt-amps per square foot. Secondly, calculate the total volt-ampere consumption of the ceiling fans by multiplying the number of fans by the assumed volt-ampere consumption per fan. Thirdly, add the general lighting load to the total volt-ampere consumption of the ceiling fans to find the updated volt-ampere calculation for the service. Finally, consider other loads and future electrical needs and consult with local experts. When determining the appropriate service size, ensure all factors are accounted for to ensure a safe and efficient electrical system. A properly sized electrical service ensures safety, prevents overloading, and provides adequate power for all electrical needs. Ignoring the additional load from ceiling fans or other appliances can result in an undersized service, leading to frequent circuit breaker trips, overheating, and potential fire hazards. Therefore, it is essential to perform a thorough load calculation, considering all factors, to determine the appropriate service size for the house. In addition to the general lighting and ceiling fan loads, other loads that should be considered include major appliances such as refrigerators, stoves, washing machines, and dryers, as well as smaller appliances such as televisions, computers, and kitchen gadgets. HVAC systems, including air conditioners and heaters, also consume a significant amount of power and should be included in the load calculation. Furthermore, it is essential to account for any specialized equipment or appliances that may be present in the house, such as electric vehicle chargers, hot tubs, or swimming pool pumps. Each of these loads should be carefully evaluated to determine its volt-ampere requirements, which should then be added to the total load calculation. To ensure accuracy, it is recommended to consult the nameplate information on each appliance or piece of equipment, which typically provides the volt-ampere or wattage rating. If the wattage rating is provided, it can be converted to volt-amperes by dividing the wattage by the voltage. For example, a 1200 watt appliance operating at 120 volts would have a volt-ampere rating of 10 volt-amps. In addition to considering the individual loads, it is also important to apply demand factors, which account for the fact that not all appliances and equipment will be operating at the same time. Demand factors are typically specified in the NEC and vary depending on the type of load and the number of appliances. For example, the demand factor for general lighting in a dwelling unit is typically 100% for the first 3000 volt amps, 35% for the next 8600 volt amps, and 25% for the remaining volt amps. By applying demand factors, the calculated service size can be reduced, resulting in cost savings. However, it is important to ensure that the demand factors are applied correctly and that the resulting service size is adequate to meet the actual load requirements. In addition to consulting the NEC, it is also recommended to consult with the local utility company, which may have specific requirements or recommendations for service size. The utility company can provide valuable insights into the expected load characteristics of the house and can help determine the appropriate service size to ensure reliable power delivery. Furthermore, it is always a good idea to consult with a licensed electrician who can perform a thorough load calculation taking into account all factors and can provide expert advice on the appropriate service size for the house. A licensed electrician can also ensure that the electrical system is installed in accordance with all applicable codes and regulations, ensuring safety and reliability. When calculating the electrical service size, it is important to consider not only the current load requirements but also the potential for future growth. As technology advances and lifestyles change, the demand for electricity is likely to increase. Therefore, it is prudent to allow for future expansion when determining the service size. This can be achieved by oversizing the service or by installing a service panel with spare capacity. Oversizing the service will provide additional capacity for future loads, while installing a service panel with spare capacity will allow for the addition of new circuits and appliances as needed. It is also important to consider the potential for electric vehicle charging, which is becoming increasingly popular. Electric vehicle chargers can draw a significant amount of power, especially when charging at higher levels. Therefore, it is essential to account for the potential load from electric vehicle charging when calculating the service size. In addition to the load calculation, other factors that should be considered when determining the electrical service size include the type of service entrance, the size and type of conductors, and the overcurrent protection devices. The type of service entrance will depend on the available utility service and the location of the house. The size and type of conductors will depend on the calculated load and the voltage drop requirements. The overcurrent protection devices, such as circuit breakers or fuses, will protect the electrical system from overloads and short circuits. All of these factors should be carefully considered to ensure a safe and reliable electrical system. In summary, calculating the electrical service size for a house requires a thorough understanding of the NEC, a careful evaluation of all loads, and consideration of future growth potential. By following the steps outlined above and consulting with local experts, you can ensure that the electrical service is adequate to meet the needs of the house and its occupants. In addition to the points already mentioned, it's vital to ensure compliance with local building codes and regulations which might have specific requirements exceeding those outlined in the NEC. These local codes often address specific environmental conditions, regional practices, or unique architectural considerations. Ignoring these can lead to costly rework and potential safety hazards. When calculating the total volt-ampere load, consider the diversity of loads and apply appropriate demand factors. Diversity factors account for the fact that not all loads will operate simultaneously at their maximum rated capacity. Applying these factors judiciously can help avoid oversizing the service entrance, leading to cost savings. However, exercise caution and ensure that the demand factors accurately reflect the actual usage patterns. For instance, a household with multiple occupants may have higher simultaneous usage than a single-person dwelling. Carefully review the NEC tables and consult with a qualified electrician to determine the appropriate demand factors for each type of load. Also, remember that the service entrance equipment, including the service panel and associated components, must be rated for the calculated load. Verify that the panel's busbar rating is sufficient to handle the total current draw, and ensure that all circuit breakers are properly sized and installed. Improperly sized components can lead to overheating, equipment failure, and potential fire hazards. When selecting conductors for the service entrance and branch circuits, consider the ampacity, insulation type, and environmental conditions. The ampacity of the conductors must be sufficient to carry the calculated load, and the insulation type must be appropriate for the operating temperature and environmental conditions. In wet or corrosive environments, use conductors with moisture-resistant or corrosion-resistant insulation. Consult the NEC tables to determine the appropriate conductor size and insulation type for each application. Grounding and bonding are critical for electrical safety. Ensure that the service entrance is properly grounded to a grounding electrode system, and that all metallic enclosures and equipment are properly bonded to the grounding system. Proper grounding and bonding provide a low impedance path for fault currents, minimizing the risk of electric shock and equipment damage. Refer to the NEC for detailed requirements on grounding and bonding. Surge protection is another important consideration, particularly in areas prone to lightning strikes or power surges. Install a surge protective device, or SPD, at the service entrance to protect sensitive electronic equipment from voltage transients. SPD diverts surge currents to ground, preventing them from damaging connected equipment. Consider installing additional SPD at subpoles or individual circuits to provide more localized protection. Future-proofing the electrical system is a wise investment. Anticipate potential future loads such as electric vehicle charging, solar panel installations, or additional appliances, and size the service entrance accordingly. Installing a larger service entrance and panel than currently needed can save significant costs and headaches in the long run. Also, consider running conduit for future circuits, making it easier to add new wiring as needed. Documentation is key for electrical installations. Maintain accurate records of all load calculations, circuit layouts, and equipment specifications. These records will be invaluable for future maintenance, troubleshooting, and upgrades. Create a panel schedule that clearly identifies the load served by each circuit breaker, and label all wiring and equipment accordingly. Proper documentation ensures that the electrical system can be easily understood and maintained. Finally, remember that electrical work can be dangerous. If you're not comfortable working with electricity, hire a qualified electrician to perform the work. Electrical work should only be performed by individuals who are properly trained and licensed. Always follow safety precautions, such as disconnecting power before working on electrical circuits, using appropriate personal protective equipment, and testing circuits to ensure they are de-energized. By following these guidelines, you can ensure that the electrical system is safe, reliable, and meets the needs of the house and its occupants.